Hello everyone. So today I'm gonna explain you how to solve n queen problem. So the description is the n queen puzzle is the problem of placing n queens of an n cross n chessboard such that no two queens attack each other. So if you know how to play a chess, you know what I mean, right? So we cannot place more than one queen in a single row or on a single column. You can see. So queen can attack an whole row, whole column, and diagonally, this diagonally and this diagonally, right? So if we consider this queen, then it can attack the whole row, whole column, this diagonal and this diagonally, right? All right. So this is the printout pattern. So in the chessboard of 4 cross 4, we can place 4 queens, uh, this by two types, right? This and this. So I have already coded this and I have already submitted this. So I'll walk you through code with explaining first how I have solved this, how I figured out the approach, right? So let's take initially for 4 cross 4 matrix. All right. So this is our initially, let's say 4 cross 4 matrix. Let's consider first this only, right? So first we will put our queen. Let's make the queen. Let's suppose set the initial for queen. Suppose this is a queen. Okay. Color will be red. Okay. What is this? All right. Suppose this is a queen. We placed it here. First queen here. We placed it here. All right. Then this whole row is this whole row. I will select this whole row will be visited. I'll mark visited as black. So this right. And this whole column will also be visited. Okay. And this diagonal will also be visited. All right. Now we cannot put this queen in any of this first row, means 0 index. I'm taking as index 0 1 2 3 and 0 1 2 3 4 cross 4, right? Now we will iterate in the second row. Now we cannot put here, we cannot put here, but we can put here. Okay, let's put it the queen here. Okay, now again this will be, this whole row will be visited, and this whole column will be visited. Okay, and this diagonal will be visited, and this diagonal will also be visited. All right. So now we came to the third column. So we cannot place the queen here, we cannot place the queen here, we cannot place the queen here, we cannot place the queen here. So if we cannot place the queen in any of the row, then we have to return from here, right? So now let's return and let's backtrack. This is also marked as visited. This. initially. Now let's return and let's backtrack. First we will delete this queen from here, then mark unvisited this one. Alright, this will be unvisited. This will be unvisited. This has already been visited by this one, and this is also unvisited. Yeah, alright. So this is previously visited by this one. Now we can place our queen here. So we will place the queen here. Let's place the queen here. Right. Now we will mark this diagonal as visited. I mean this column as visited. Right. Then we will mark this column as visited. And also mark this diagonal and this diagonal as visited. Now we will iterate in the third row. So this is already visited, this is not visited. So we'll place the queen here. Okay. Now we will mark all the row of this as visited, all this row as visited. All the diagonals this visited and this diagonal as visited. Alright, now let's go to the fourth row. Now here see, all the cell in the fourth row is already visited, so we will return back from here and marked as unvisited. So let's return back. Return back. Now see, by keeping our queen here, we cannot we tried here, right? So it is not possible to place an queen by keeping our queen here. So we'll shift the queen from here to here and mark this as unvisited. Alright. Why the color is different? Capacity is increased. Okay. Now we will place our queen here. It is smaller. Let's place the queen here. Then mark this. Mark a whole row as visited. So we'll mark it by black. Mark whole column as visited. Mark this diagonal as visited and mark this diagonal as visited. Alright. Now after this we'll move to the second row. So this is already visited, this is already visited, this is already visited, this is not visited. So we'll place the queen here. And mark whole column as visited. Okay, mark whole row is already visited, this is already all visited. Mark the whole diagonal, this as visited, and mark this side diagonal is visited. So see, this is already done. Now we'll move to the third row. Now this is not visited, so we'll place the queen here and mark this row as visited, this whole row as visited. So let's mark it, mark visited, and whole column, this first column as visited. So let's mark it as visited now, and diagonal is already visited, so no need to mark it. So we'll go to the fourth row. Then this is the only place where we can place our queen. So now guys, so we have placed the 4 queens in 4x4 matrix. So this is how we have to do it with the help of backtracking, right? This is how we have placed 4 queens in the 4x4 matrix. So I'll walk through the code. So here is the code. If you see in the code now, it looks like big, like what I have written. Okay. But actually the code is, the core part of this solution is only this 3 line, this 3 line, this 3 line. First we have to mark visited, then call the solver function, then mark unvisited. Okay, so this, this solve function is the logic, actually is the actual logic, and rest are the subsidiary, only for marking visited and non-visited. See, this whole is for marking unvisited, and this whole function is for marking visited, and this is for string operation. That's it. So this is the whole core part of the solution. So what we will do is, initially I will pass the row 0th row. So I'll iterate from j equal to 0 to j less than n in that entire row, right? So if visited of ij is 0, then what I will do, I'll get the string for this. I mean, we have to output like this, right? Dot q dot 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 q. So for that, what I have done, I'll explain you this. So here get string, what we will do is, I'm passing as a parameter as int j int n, and then creating a string str and iterating from 0 to n, and if j equal to k, then only I will push q, otherwise I will push dot, then I'll return string from here. All right. Now after returning the string, I will push the string into vector of a string. This vstr is the vector of a string. Then here is the base condition. If I equal to n minus 1, that means we are already in the last row, and we have inserted our queen. Now we will push the final vs the vector of a string in the result, then return from here. Okay, no need to go here. And if this is not the last row, then what we will do is, we'll mark visited ijn, as I showed you, right? How we have marked the visited here. So we will mark visited the whole row, whole column, and both diagonal ijn, then solver function, then mark unvisited. So I'll explain you how I have marked the visited. Okay, so this is our mark visited. Let's color it. Let's color it with this So this is our mark visited, this function mark visited. So this for line, this will mark whole row as visited, and this column and this line will mark whole column as visited. So instead of equal to 1, I'm doing plus plus, because uh, the problem was, I'll explain you what is the problem. Because the thing is, uh, there are multiple uh, visited. Actually, the thing is, this is already if we place the queen here, right, then this fourth column cell is already like visited, and if we put this, then this is getting visited to 2 times. So we have to keep count also. Otherwise, while unvisiting will unvisited will mark this cell as unvisited. So this will create a problem for us. So that's why I have done this. So I'll increment instead of just putting as 1. Now this is a diagonal operation. First I will increment j plus plus and j minus minus. You can easily get if you know the diagonal indexing. Then j I minus minus j plus plus, then I plus plus j plus plus, then I minus minus or j minus minus, and this is our condition. While I greater than equal to 0, and then I less than n, and then j greater than equal to 0, and then j less than n, right? Until this we have to keep marking visited. Similarly for unvisited, instead of plus plus, I have just put it minus minus here, minus 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 minus, visited minus minus, visited minus minus, visited minus minus. That's it. So this is the only core part. This is the only core part of our solution. This way. And among them, only these 3 lines are the most important thing. Mark visited, then call solve function with the row increment I plus 1, then mark unvisited. Mark visited, then increment I plus 1, then mark unvisited, right? So this is how I have solved it. And yeah, I have declared the visited array globally here on the top. Yeah, visited array globally and result as globally. Also, you can also try to pass from the function, but I like global declaration because it reduces the amount of code. So after that, I have initialized the memset with 0, visited array with 0, and cleared the result vector, then created a vector of a string vstr, then call the solver function, then return result from it. So guys, I hope you liked, you understood this approach, right? So I have already submitted this. Alright guys, so thank you so much for taking your time. Comment down if you didn't understand anything. I'll try to answer it, and suggest please dislike the video if you do not like it and if you do not understand it, and tell me exactly how I can improve my approach to explain. So thank you so much everyone.